Hi everyone, this is a short video for helping you complete trial topic test 3. We're going to move very quickly through the answers. You can stop and pause and rewind when watching this video. So let's get underway. Okay, let's just square that up a little bit. We've got a fictitious country of Catatonia as a central government which is responsible for the 15 regional areas called shires. Each of these shires, I think we've read through this a few times, this one. The Catatonian government ran a campaign highlighting the importance of environmentally friendly behaviour, such as using public transport, conserving water, etc., etc. And they've got the results from a sample of 200 residents from the Shire of Banthul. So we're going to go have a look at some of these questions from here, and our first one is, what percentage of Catatonians compost their food scraps? So that was a SPSS frequency, so across we go to analyse, descriptives, and just lost it, frequencies, and we're asked to look at do you compost across there. Now, what percentage of people in your sample, if you give your answer to the nearest whole number and do not include the percentage sign. So let's just have a look at that. So we use a bar or a pie chart, wouldn't we, when we're doing that? And we're looking at percentages there, and well, then let's have a look at what we get here. Okay, so that's the main one we're interested in, is the little frequency distribution chart there, and we can see that the people that the people that do compost your food scraps is 37%, and we're going to include that there. Okay, it says, what proportion of people in the sample compost their food scraps? So we've got to change it from a percentage to a proportion, and all we do by that is, and again, making sure we copy what the question is asked, and it's asked us for 2 decimal places. It puts a 0 in front of that, and away we go. Okay, so taking it straight off of here and making sure we're not using percent, valid percent. In this case, they're the same because there's no missing people, and we have talked about that, and have a check back if you're interested to see why we use a valid percent. Using the SPSS Explore, so we're going to go up to here, descriptors, and explore. Use the weighted averages information in the table. A box plot and histogram for the length of shower. So we've been asked a few things there, so we're going to go to descriptives. Sorry about that, if I can bring it up. Nasty. Explore, and we're looking at the length of shower. So we're going to use this one, put it across. Now we're asked for produce summary statistics, percentiles, box plot, and histogram for length of shower. So we'll make sure we're getting those ones there. We want to make sure we include the percentiles. We'll include plots. We don't worry about stem and leaf. Histogram and a box plot come together, which is good for us. We'll continue, and then we'll click OK. Okay, let's just have a look. So 50% of, I'm going to move down here to our percentiles and just have a look. All right, so 50% of the percentiles in my sample spend more than how many minutes in the shower? We've got to round that, don't we? So round it down to 3 and to 4.81 minutes. Okay, have a look at your rounding if that's a little bit of an issue for you. 25% of the people in my sample spend less than, so we come to the 25th, that's 25% and less, and they will 6, we go up to 1, so 3.8. 3.8. That's not very good. 3.81 minutes in the shower. 25% of people in my sample spend more than. So we come up to the 75th percentile because there's 25% of people are more than, and we have 6 up to 6 up to 0.02 minutes in the shower. Let's move along. Compare the distribution of shower time in your sample to the distribution of shower shown in figure 1. So they're using the box plot, not the histogram, so let's have a look at that one. and we've asked some questions. My sample has a lower median, my sample has the same median, my sample has the higher median, the sample pictured in figure 1. So we just need to have a look at what our median actually is, and we can read that off of the percentiles. We've got it up here in our descriptives, and we can read it off of our chart across there, which is about 5. The median in this bar box plot is 6, so we can say that my sample has a lower median than the one in sample picture there. I'll show you in a minute how we can change those to include those so we can read it a little bit easier. Compare your box plot to the box plot shown in figure 1 and select the correct statement. So let's go back to here. So we're talking about the variability, and our the shower time is less variable. And the reason it's less variable is we can look at a couple of things there, but we're looking at our high is up to 11. Ours is nowhere near that for our highest score. Our lowest score, so that would give us the range, and also looking at the spread of the scores here, so we can say that my sample, the shower time, is less variable, so there's less variability in the data that we've collected. Use the chart editor. This is one that people are having a lot of trouble with, so we'll go through here, and we want to change a couple of things on the histogram, and it's basically to do with binning. So the intervals is another word for binning. So using the chart editor, we'll just get this up first. The chart editor, how do we get that? Simplest way is just to double click on the chart, and you can see at the top there it brings up chart editor. Okay, we then will just anywhere on the graph, and we bring up the properties. Yours might look slightly different because I've got an older version of SPSS, but don't panic. Okay, so we want to, so the first column starts at 0. Okay, so we want to do that. We want to make sure the first column starts at 0. 0, I don't think it matters there. And what we other want to change is we want to change the distance between the intervals, the size of the interval. So we're going to go to interval width, and we've been asked to change the bin width or interval width to 0.5. Okay, so that's the width of the intervals down here. Let's apply that and see what it changes to. Okay, so we've now got 2 to 2.5 to 3 to 3.5 to 4. Now to have make sure we can look at that, we can change the scale there if we wanted to, and again the major increment, and we'll change it to 0.5, and let's have a look. And it just means we can read that off a little bit easier. And if we want to change this one, we can double click on what the information we want. The major increment is 10, let's make it 1, and then we can read off what we're looking for. So between 2 and 2.5 minutes, how many people in your sample had shower times? That will be here, 2 to 2.5, up to here. We can even put lines on this, but we don't want to labour the point, and that would be 8, which we've got in here. Okay, so hopefully that helps a bit with people changing the things around on your histogram. For this sample of Catatonians, give the mean, the standard deviation of shower time. Give your answer to 2 decimal places, for example 5.37. So again, it's showing you what we like. So for us, there's a few different ways. Well, the mean is 4.86. We can just get it straight off of the chart. And the standard deviation is 1.54. And for those, we can get it, let's just get rid of the chart. We can get it off of our descriptives, and we can get it off of our graph there, or even reading it off the graphs. Okay. Question 8. In a random sample of 50 Catatonians, 3 were employed full-time. What percentage of residents in the sample were employed full-time? Okay, give your answer as a whole number. So if we had a sample of 50, by doing our maths is 3 divided by 50, that will give us 0.06, I think, but anyway, it's 6%. Okay, what percentage we're asked for? All right, with the percentage sign. Sorry, almost missed it myself, so we've got to make sure we answer those questions. Suppose we were describing the distribution of ages of residents in a retirement village. Age was measured in years. Which would be the most appropriate graph? Well, because we're measuring something that's a metric data, ratio interval, or other words for that, we'd be using a histogram. You can be grouping the ages of people together there. Suppose we're describing the distribution of sex, male, female. So that's a category. So straight away we could say a bar chart's going to be better for that. And suppose you want to describe the distribution of hours sleep. Hours of sleep is going to be a number, a metric variable. So we're going to go through frequencies or explore, and we know that on SPSS, when we're looking at metric variables, we go descriptives and we go down to explore, okay? So we'll tick that one. Coming along, there's a lot of questions. So the distribution of expenditure on food for a sample of people on a day trip. All right, so they're measuring people, how much they spend to go out on a day trip for this company. Which of the following measures will give best indication of a typical expenditure in our sample? We're probably going to say the mean here because we can see that it's a nicely normal curve. Okay. If the distribution was a little bit skewed, we'd probably say the median. If it was a chart with a count, we'd say the mode. And we're not really worried about the spread of the data. We're just sort of looking at what is a typical sample, okay? Are Catatonians satisfied with their jobs? Use the frequency table below to answer the following questions. In this sample, for those Catatonians who are employed, what percentage are satisfied with their job? So again, just reading off the chart here, but give your answer correct to one decimal place and do not include the percentage sign. So again, we're going across, we're asked which ones were satisfied, must have good jobs or whatever they do, all government workers maybe, 79.6, and we use the valid percent because there are people here that are missing, so remember to use that. And we said one decimal place, 79.6. Okay, hopefully we're all across that, and you can see what missing cases, the people that didn't answer or don't become part of it, it really affects the different amounts. It doesn't affect the amount, which one is we're happier with, but it does affect those totals there, okay? So we always use the valid percent. Question 14, a manufacturer of children's clothing was interested in what colour dresses were preferred by young girls. They randomly selected 200 5-year-old girls and showed them 4 dresses, all in the same style, but in 4 different colours. The girls were each asked to select the dress they like most. Use the attach. Okay, so we're just going to use the one to describe what we've got. And again, making sure we use the valid percent. The distribution of preferred dress colour sample of 200. And what have we got? Randomly selected 200 5-year-old girls. So let's see if that's in our, 5-year-old girls is displayed in figure 1 down the bottom here. The most common preference for the dress was pink, 56%. So we'll do pink, 56%. Here we go. But the purple dress, as you can see here, was 32 was next, and that was of 32%. Okay, just simply reading off of the chart there. Question 15. A community welfare group is concerned about the cost of electricity, people living on a pension. They take a random sample of pensioners and record the size of their last electricity bill. Use the attached SPS to complete the following description of the distribution. So again, let's have a look at this. The distribution of the amount of electricity, a random sample of, okay, and we can see, well, it doesn't show us, does it? Where does it show us? Down on the graph, the number is 200. If it doesn't say, it's always in there. So we'll put 200 pensioners displayed in figure 1. The distribution is approximately symmetric, and the average bill was, well, we can read that off of 280.33 there, or we can see it down here as well. So 2 places you can get the mean there to check, 280.33. And the standard deviation, again, we can do it. Sorry, standard error, that's no good. Standard deviation 19.59, or again 19.59. Let's just finish this one up before we have to go to part 2 of the video. And $266. So we're looking at the confidence intervals here of 266, not the confidence intervals, sorry, the percentiles between 266 and 294. 266 and 294, because 50% of the amounts falling within this. So a little bit of a slip up by me saying that the confidence intervals there. We're just looking at describing the distribution, okay? And we'll see you in part 2.